In example 13.9, we're going to consider Halley's Comet. This comet moves in a highly elongated elliptical orbit about the Sun as shown in this diagram. The distance from the Sun at perihelion, where it's the closest at this point, is given here, and the distance at aphelion, where it's the furthest, this point, is given by this value. With these two values, we like to find the semi-major axis, the eccentricity, and the period of the orbit. So we'll begin with the diagram of the orbit to sort out its geometry. The semi-major axis is defined as 1/2 the distance from perihelion to aphelion, shown in the diagram. And we have two foci, of course, for the ellipse. The Sun sits at one focus, there's nothing at the other focus, and the eccentricity is defined by E, such that E times A is the distance from the focus to the origin. The equation that we'll need for this problem is Kepler's third law of planetary motion, equation 13.17, shown here. So the first thing we're going to do is calculate the semi-major axis, and all we have to do is take the average of the perihelion and aphelion distances, and we get this value. Now this perihelion distance, of course, is the distance from this point to that point, and that must be equal to A minus E times A, as given here. We can factor the A out in front, and this must be equal to 8.75 times 10 to the 7 kilometers. We have A, so now we can calculate E, and we get 0.967. Finally, once we have A and the mass of the Sun, we can find the period of the orbit, and this turns out to be about 75 years. The comet was last at perihelion in 1986. This means that it won't be back into perihelion until the year 2061. And this ends example 13.9.